this is question number 35 from the August 2016 Geometry Regents exam. So we've got a proof to do in this problem. What we're trying to show is prove that the lines from AE to EB, if we want the product, is equal to the product of the distance from CE times the distance from E to D. Now, the strategy we're going to do with this is to create two triangles and prove that they're similar. Once we've shown that they're similar, we can create proportional ratios and some cross multiplication to get to this final proof, this product equation. So that may sound kind of confusing right now, but hopefully as I go through it, it'll make sense to you. So of course we'll start off with a statement given the information that we know. We know we've got a circle O, chords A, B, and CD, and they intersect at point E. And the reason is given. The next thing we're going to want to do is draw two chords that connect C to B and A to D. Now that we've got these two triangles drawn, our goal is to show that they're both similar. The first thing we can do is state that the angle CEB and AED are congruent. And we know that's going to be true because they're opposite angles. We can also state that angles C and A are congruent, and we know that's the case because they're both inscribed angles that are connected or subtended by the same arc. They both connect to B and D, the arc BD. Alright, so now at this point we can conclude that the two triangles are similar, knowing the angle-angle theorem. Okay, so now that we're dealing with two similar triangles, we can create two equivalent ratios because we know that the corresponding sides of two similar triangles are going to be proportional. So you can see the statement I made, the relationship of AE over CE is going to be equal to ED over EB. And again, that reasoning is because the corresponding sides of similar triangles will always be proportional. And now we're getting to the final point of the proof. We're going to get to this final statement by doing cross multiplication of these two ratios. So you can see the final statement there has now proven this theorem, and the reasoning is cross multiplication, or you may have also heard it as the means extremes property of proportions. All right, pretty lengthy process, but I hope everything in that question made sense. And that is it for this video. Thanks for visiting JD's Regents Preparation.